Now here for question 11, this is a sequences question. So we can just trial and error. Since we want z to be as small as possible, let's work on the geometric series. And since both only contain integers, z must be a cube. So if z is equal to 8, then x and y are not integers because the difference between z and 1 has to be a multiple of 3. So next up is 27, which also doesn't work. And then after that is 64. Now we notice that 64 works, so then this sequence is 1, 22, 43, 64. And then the other sequence is 1, 4, 16, 64. So now if we add up all the values, we get 149, so the answer is E. So here, Carlos is making a passcode. So we notice that 2 is the only even prime, so we have two cases. Case 1, there is a 2. So that means that we have 4 ways to put the 2. And then afterwards, if we list out all the numbers, and we take out all the evens and all the primes, we're left with 1 and 9. So then there are 3 spots left, and each spot has 2 choices. So it's times 2 to the 3 equals to 32. Case 2, no 2 exists. So now we have 4 places to choose the even number, and then 3 choices for the even number, and then 3 choices for the prime, and then 3 choices for the number that is the prime. And then afterwards, there's 2 spots and 2 possible digits, which is 1 and 9. So we have 2 to the 2, and this is equal to 432. And now if we add this up, we get 464, so the answer is D. Here we're looking for the shaded portion, so without loss of generality, we can let the square have area 1 because we can just scale it up or down. So now we can label the next square, so this is k squared, and so on. So now we have 64 over 100 is equal to 1, and then minus k squared plus k to the 4 minus k6, blah, 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 and divide by 1. So now we can use the geometric series formula. So we have 16 over 25 equals to 1 over 1 plus k squared. We have k squared equals 9 over 16. Yeah, 16. So we have k equals 3/4 because it's positive. So we have D. Now question 14. So in total, we have 6 choose 2 ways to place the students and 4 choose 2 ways to place the teachers, which is 90. For our desired, we can just place the students together. So there are 6 ways to do that. And afterwards, if we draw it out, let's say these 2 are occupied. So then there's 1, 2, 3 ways to choose the teachers, which is 18. So this means that 18 over 90 goes 1/5. So the answer is B. So here is problem 15. We can start labeling our lengths. So AB is 1, this is 1, 7, and AD is 5. So first, we notice that we can find DE because AE squared equals 7 squared plus 1 squared equals 5 squared plus DE squared. So from this, we have DE squared equals 25, so DE equals 5 because a length is positive. Now, afterwards, we notice that triangles ABC and EDC are similar because they have two shared angles. So now let's let this be x, so that this is 7 minus x. And so now, since the ratio between EDC and ABC is 5, we have that AC equals 7 minus x over 5, and then DC equals 5x. So now we have an equation. We have AD, which is 5, is equal to AC plus CD. So we have 7 minus x over 5 plus 5x. So now we have 25 equals 7 plus 24x. 18 equals 24x. So x equals 3/4. So now the area is just half of base times height, which is 3 over 8. So it's A. So here we have problem 16. So we can split this up into 3 cases. Case 1, 3 coins. So the probability that this happens is 3, because we have 3 jars to choose from, over 27, because each coin has 3 choices, so it's 3 to the 3, which is 27. So this is the probability, and then we multiply by the value, which is 3, which is 1/3. Case 2, 2 coins. Here we have 3 ways of choosing the jar that gets 2 coins, 2 ways to choose a jar that gets 1 coin, and then 3 ways to choose the coin that's in the jar with 1 coin. And this is all over 27, and this is times value, which is 2, to get 4 over 3. Finally, case 3, 1 coin. We have 3 ways to pick the coin in the first jar and 2 ways in the second jar, over 27 times value, which is 2 over 9. So now if we add this up, we will get 17 over 9. So the answer is D. Now here, problem 17 is a number theory problem. So basically, we notice that n is the divisor of 273420, and n is also a divisor of 272745. So now we can use Euclidean algorithm to take their GCD. So 273. Larger one minus the smaller one, so this would be 675. And eventually find that GCD is equal to 45. So that means that n is a divisor of 45. In other words, n equals 1, or 3, 5, 9, 15, or 45. We see that leaves a remainder of 16, which means that n must be at least 16. So these are impossible, so the answer is 45, so the tens digit is 4. Next, problem 18, we have the polynomial question. So here, the important thing to notice is that for any k squared minus 4x, kx squared, minus 4x minus 3 equals 0, let the roots be p and q. So if we find the sum of their reciprocals, 1 over p plus 1 over q equal to p plus q over pq, which is equal to negative b over c over a, which is negative b over a, b over c, which doesn't depend on k. And so this is negative 4/3. So there are 2025 quadratics multiplied together. So this means that the harmonic mean is 1 over 4050 times 2025 times negative 4/3. And this is equal to minus 3 over 2, which is b. So next we have 19. So an array of numbers is constructed. This is similar to the Pascal's triangle, but it's with different initial conditions. But we can apply similar argument. So basically, let's say that these are our coefficients. So f of x equals this plus this. We notice that to get to the next row, we're just multiplying by x plus 1. Another thing is that the sum of the coefficients, which is these values, is just f of 1. So if we let the second row be g of x, we have f of 1 times 1 plus 1, because x equals 1, equal g of 1. So that means that for every row, it doubles. We notice that 12288 is equal to 3 times 2 to the 12. This first row is 3 times 2 to the 0. So that means that it will be the 13th row. The first row has 3, so that means that in the row we want, it will be negative 1. And the second number will be negative 9. And then the third number is just this plus 1. So this number would be negative 8 plus negative 1, and then plus 1 plus 2 plus 3 plus 1. So this is equal to negative 36 plus 7, which is negative 29. So the answer is A, negative 29. Now here, question 20. So for this one of the ways is to set a coordinate system if you don't want to do it the harder way. So let's have D equals McDonald. Let's set this to be 0, 0. Let's have the center of the silo be here at 20, 15. And here we have McGregor, which is 40, 15 minus G. Basically, we want it so that this line is tangent to the silo. So we can let this line be y equals mx, and then let the circle be x minus 20 squared plus y minus 15 squared equals 100, because it's the radius squared. So now if we sub y equals mx in, we find x squared minus 40x plus 300 plus m squared x squared minus 30 mx plus 225 equals 0. And that's because I moved 100 over when I subtracted it from 400. Right, so now we have x squared 1 plus m squared minus x 40 plus 30m plus 525 equals 0. To have one solution, we want it so that it has a double root, so the discriminant is 0. So we have discriminant squared, which is 100 times 16 plus 24m plus 9m squared equals 4ac. So it's 4 times a, which is 1 plus m squared, times c, which is 525. So now we can simplify 16 plus 24m plus 9m squared equal to 21 plus 21m squared. We have 12m squared minus 24m plus 5 equals 0. So now we can just keep solving. M equals so now we keep simplifying. We divide out 16 from the top to get 21. We notice that g is positive, so we want the lesser solution of m. So now this is a slope, and this is a slope, so it's also equal to the rise, which is 15 minus g, over 40, which is the run. So now we get 20 minus 20 root 21 equals 45 minus 3g. 3g equals 25 plus 20 root 21. Oh, right, that should be a 6. So that's a 6. So 240. So this is 20 root 21 minus 195. Let's see. Oh, never mind. Nope. That's a 120. There we go. That seems better. So that's a 75. So now if we add up all these numbers, we get 119. And